All right, boys and girls, we're looking at lesson 7.2. 7.2 is all about dividing exponents, whereas 7.1 was all about multiplying exponents. So it's going to be the same type of thinking, but because it's dividing, it's the opposite. So big key concept, the quotient of powers. To divide two powers with the same base, again, the same base is important, we will then subtract the exponents. So k to the 11th power over k to the 8th just means k to the 11 minus 8, which is k to the 3rd. Now another way that you can think of it so that you understand the reasons why, let's pretend that we have an x to the 3rd power over an x to the 2nd. This could be rewritten as an x times an x times an x over an x times another x. Now because we can simplify, when 1x divided by another x happens, that makes just a 1, and 1x divided by another x happens, that makes a 1. So you can see that we removed 2. So we subtracted by the denominator's exponent, and that's why the answer would be x to the 1st power, or just an x. So the same thing happens over here. You could draw out 11x or k's over 8k's, but if we just notice this pattern, understand that's the reason why we subtract, then we're good. Alright, so let's move forward. Here's our very first example. Same ideas, they have to have the same base, so it's kind of like we're looking at if they have like terms. One before we were working on things. So our x's, because they have a base of x, now we can subtract their exponents. So 7 minus 6 becomes just an x. Now when we look at the y's, because they're again the like terms, y to the 12 divided by y to the 3rd becomes a y to the 9th, because 12 minus 3 is 9. So then this would be the simplified version of our division problem over here. X times y to the 9th. Alright, let's keep it cooking. We're doing pretty good. Remember the power of a quotient. Now this is very similar to what we did yesterday, that this power of a 4 moves to the numerator and the denominator. So not only does the 3 get it, but the 5 also gets the power of 4. If we have just regular numbers, we're going to simplify them into actual values of whatever 3 to the 4th is, which is 81, and 5 to the 4th, which is 625. So you will actually compute if you're dealing with a coefficient or just a regular number, like in example 2, we have a 4 and a 5 here. So this 3 gets to all parts of our problem. So it's going to be a 4 to the 3rd times a c to the 3rd times a d to the 2nd to the 3rd over a 5 to the 3rd. Now I'm showing you this just so that we can be truly understanding the reason why we do what we do. Later on we can just go quickly through this now that we understand it. So I take my trusty calculator, 4 to the 3rd, because I don't want to make any simple mistakes. I go ahead and type it in, I get a 64. A c to the 3rd. Remember yesterday when we had a power to a power, we multiplied. So this becomes a c to the 9th. Same thing here with our d. A power to a power, that becomes a d to the 6th. Now 5 to the 3rd power is going to be again 125. Double check to make sure we don't make any simple math mistakes. And then we go ahead and plug that in. So if I could simplify like we did on the previous problem where they were the same C's on the bottom or D's on the bottom, we would. If 64 and 125 can simplify, we would. Alright folks, let's try some more difficult ones. Now we've talked about this a few times during class, the reason why a 0 exponent is always 1. And so if we just remember that process, every time you have an exponent of 0, we know that the answer is 1. So make sure you write that down as your vocabulary words, or just so that you understand again that a exponent of 0 means whatever it's being raised to the 0 power, the stuff inside is 1. So because in example 3 we have this whole quotient, or this whole division problem is to the 0 power, that means this entire answer is just 1. So there's not a whole lot of work that we actually have to do there, because we know that anything to the 0 power is 1. On this problem, you're going to try it by yourself, but remember what we've talked about with the previous problem. So try that on your own. We're going to check it when you get back to class. All right, another big idea here, folks, and this is a little bit more of a difficult concept for some of us. If I have a negative exponent, the way that I get rid of that negative exponent is by bringing it to the bottom or the opposite side. So this would be over 1 if we were talking about fractions. So we bring the whatever is raised to a negative power, we bring that down. Or in this case, we bring it up. So that's how we are going to remove negative exponents. We just bring them to the bottom or to the top of the fraction. So in example A that we will do together are things that we're going to move from either the numerator to the denominator or the denominator to the numerator are going to be my negative exponents. So I have this guy needs to move, and I forgot to write down the other one. We'll get it here just a second. And the z to the -6 also has to move. So the way that we do this, again, folks, is we're just going to move the sides. So when I rewrite my answer, I'm going to have a y to the 9th, which stayed up there. And this z to the -6 now comes to the top, and it removes the negative, so now it's positive. And then this x to the -4, to turn it positive, has to be put to the bottom. So x to the +4th is now on the bottom. Now again, just like we did before, if we had the same bases, like if there was another set of y's at the bottom or another set of z's or x's at the top, we would be able to simplify even further. And that process may just happen in problem B here. So we're going to try that one on our own as well. So we have 2 problems that you're going to bring to me to class tomorrow that we're going to check to make sure that we understand things. All right, folks, that's how we divide with our exponents. Enjoy your time with this stuff. Hopefully you can pause and make sure you write down all the information. Good luck, and we shall see you next time. This is Burmanation signing off.